Okay, good morning, good afternoon, and good evening to everyone, wherever you are watching me from. Welcome back to our lesson in statistics, or others would say decision-making techniques. So in the previous lesson, we are looking at descriptive statistics, more especially on the aspect of the central measure of tendency, where we were talking about the measure of location, and also where we were talking about the measure of spread or variability in the previous lesson. So if you did not watch the previous lesson, you're not allowed to watch this one, because somehow you might get confused. So we're talking about knowing the aspect of, or maybe understanding the aspect of grouped data, and understanding the aspect of ungrouped data, even as you're trying to measure these numerical values. So the numerical values can be in the form of the central measure of tendency, or can be in the form of the measure of spread. So under the central measure of tendency, that's where we have the aspect of the mean, mode, and the median, those cases. So the mean, mode, and the median, that's where we're finding the measure of location, or maybe the measure of central tendency. But when you look at that is the measure of spread. The measure of spread, we are looking at how the data values tend to be spread, or maybe the variation between each data value to the mean. How does it vary, or how are they spread from each data set to its mean? How are they spread, or how are they varied? That's what we're trying to talk about in the measure of spread. So in the previous lesson, I think we talked about more of ungrouped data, where we simply said the ungrouped data is just basically data. In short, we are having raw data there. That's basically the ungrouped data. It's basically raw data. So for example, the way we are solving question 1 here, this is basically data which is not grouped in any form of visual description. It is just been given to us without any order, randomly. So it was just basically raw data collected there and then, without any order and without any classification. So there are two types of data. When you collect your data, the data can either be grouped or ungrouped. So that is why in the previous lesson we focused more on the ungrouped data, where the data given had no any kind of order. So where we talked about finding the mean of such a data, finding the median of such a data, finding the mode, finding the variance, finding the standard deviation, and so forth and so forth. But today we'll be looking at the aspect of grouped data as well. So we'll be looking at the aspect of grouped data. So we'll look at the measure of central tendency and spread for basically grouped data. But first thing is first, what is this grouped data? What is this grouped data which we are trying to talk about? So we have to understand that when data is grouped into classes, so when we are looking at aspect of we've collected our raw data has been collected without classification, that is basically ungrouped. But if you look at the video we made before the central measure of tendency, we were trying to group our data in the previous videos. For example, where, let me give this scenario here. So we had such an example here where we had these types of data. So if I look at all these types of data here given to me here, this is raw data, this is ungrouped. It can only become grouped if we construct, or maybe we put it into a frequency distribution, then it becomes grouped. So once this data has been collected, put it into classes, we classify this data into specific classes. Remember how we are classifying this, or maybe how we are grouping this, or how we are forming a frequency table. The first step was you form the number of classes. The second step was you find the range. The third, you find the width, and then you continue by finding the class marks, or maybe the midpoints. So this is how basically this is going to happen. Once this data has been put in a table, so once this data has been put in a table, we are going to have something to do with, we are no longer going to have ungrouped data. By this time we are going to have grouped data, because the data which we had in the first place was ungrouped. Now it has been grouped into certain classes. So this is basically a simple example I can give when we're trying to explain the aspect of group and ungrouped data. So this, what I have is ungrouped. Once classified and put into a table, once classified and put into a frequency distribution, then it becomes grouped. So this is what we are trying to say here. When data is grouped into classes, when data is grouped into classes, so for example, we are grouping things maybe from ranges of 10, the width of 10, from 10 to 20. Maybe this was scores obtained by various students, and then you are trying to group it into classes. So class number 1 can be a collection from 10 to 20, class number 2 can be a collection from 20 to 30, class number 3 can be a collection from 30 to 40. What I've done here, I've basically grouped into classes. So I'm trying to group every data collected into its class. Then what we are simply saying that we no longer have the individual rows, but we basically have, we no longer have the individual row data points. So what we'll be using to perform any kind of numerical measure, what we'll be using midpoints. So it means we'll have to calculate the midpoint for each and every case. So we'll be using midpoints in this case instead of using the actual data values. So remember, when data was ungrouped, like in the previous case, this one, if I was to find numerical values, I will use the actual values and maybe if it's finding the mean, everything, sum it up, divided by the number of observation. But for grouped data which has been classified into intervals, or maybe into classes, we are going to be using the midpoints to calculate for any numerical measure. So the question comes in to say, how do I find this midpoint? So we'll be looking at how do I find this midpoint. So this midpoint will be calculated by the formula as follows. So the midpoint will now be calculated as lower limit minus the upper limit divided by 2. So we'll be looking at the lower limit minus the upper limit divided by 2. So this will be the formula for the midpoint. Lower limit minus the upper limit, not minus, but lower limit plus the upper limit divided by 2. So we are summing up the upper and the lower limit. So if I classified my data into intervals, maybe into widths of 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so forth. So it means for me to find the midpoint for the first class will be 10 plus 20, which is a 30, divided by 2, which is going to give me a 15. So 15 will be the midpoint for class number 1. So class number 2, we go again, 20 plus 30, which is giving me a 50. 50 divided by these 2 there, then I'm going to have the second midpoint. So 50 divided by 2, which is a 25, and so forth and so forth. So in grouped data, every time when we want to find the measure of numerical measures, what am I using? I'm using midpoints to use, and not the individual row data. So those individual row data have been classified into classes. So now we'll be using midpoints instead of individual datas. So the midpoints will now be lower limit plus upper limit divided by 2. As simple as that. So this is how basically our midpoint will be calculated. Now let's go dive into the direct thing of the central measure of tendency. How we are going to measure the central measure of tendency there. So we say that the central measure of tendency is basically the measure of the what? The mean, mode, and the median. So let's look at it. We looked at the central measure of tendency for grouped and grouped data, but this time around we are looking at the aspect of grouped data. In the previous lesson it was ungrouped data, but this time we are looking at grouped data. So even in the formulas, pay particular attention to your kind of data. Are you measuring the central measure of tendency for grouped data, or are you measuring the central measure of tendency for ungrouped data? So you look at your formulas given. Last time in the previous video we said that when I'm measuring the central measure of tendency for grouped data, there will be certain formulas we'll be using based on the population or based on the mean. Remember, a population and the sample. So a population is basically a large group which has been studied. So the all desired characteristics are being studied at this particular point. But a sample is just basically a subset from a population. So a population is something which is very big, which you are trying to study, but when you look at a sample, we're trying to now narrow it into a small number. Instead of maybe studying 1,000 students, we just basically create a sample to say, I think instead of studying 1,000, let's create a sample. So out of this 1,000 students, maybe let's focus on this certain group, which we are going to call as our sample. So even as I am calculating maybe number 1, calculating the mean. So how do I calculate the mean? If it was for ungrouped, we just simply say sum of the data set divided by n. But when it is for grouped data, the formula changes to something else. We are looking at this guy. We're now looking at the aspect of summation. This symbol means summation of f dot x. F dot x means f means the frequency and x means the midpoint. So it means we are looking at the aspect of frequency multiplied by the midpoint. So every data set which I'm going to have, remember we had data values which have been classified in intervals, and those intervals or maybe classes, we are now able to find the midpoints. So since we have the midpoints for every class, we are getting the midpoints multiplied by the frequency. Remember, what is frequency? Frequency is how many times that midpoint or maybe that class is appearing in my data set. So frequency multiplied by x. Another class with frequency multiplied by x. So remember, if I had class like 10 to 20 and 20 to 30, another one 30 to 40 and so forth. So I'm looking at this class. How many times is this class appearing in my data values? So that is the frequency. So if this was 2, it's appearing twice, this is appearing 4 times and so forth. That will be my frequency. So frequency multiplied by the midpoint. You've already calculated the midpoint for each case. So that midpoint for class 1 multiplied by the frequency. That midpoint for class 2 multiplied by the frequency. The midpoint for class 3 multiplied by its frequency. Then you sum it up. So the summation is simply saying we are going to add everything up. Then we divide by the observation. How many data sets did we have? Or maybe this n here, which is the observation, sometimes just basically the summation of all the frequencies. We'll look at an example nicely later on. So n is basically the observations. How many data sets do I have? How many are they appearing? That's the n. So we even instructed from parameters that in the previous lesson that if I'm talking about the mean, there is a Greek word letter which we symbolize which symbolizes the population mean. which is a mu, a Greek letter mu. This symbol is basically representing for a population mean. So every time I look at a question, ask yourself, am I finding the mean from the population, or am I finding the mean from the sample? So if I'm finding the mean from the population, then I'm going to use the Greek letter mu, which means population mean. This is the symbol for the population mean. So population mean is equals to summation of frequency times midpoints. Summation of all the frequencies and their midpoints. All the frequencies and their midpoints divided by the capital letter N. We're using the capital letter N to emphasize that my data is basically coming from the population. But if it was coming from the sample, this sample will be represented, sample mean will be represented by X bar on top, like a bar on top. The same formula, summation of all the frequencies multiplied by the midpoints, but we are dividing by the observation. This observation is basically represented by a small letter n. Why small letter n? Because this is a sample is smaller than a population. So trying to represent logically using nice math, we know to say population is bigger, so it should have a big observation compared to a sample. So ask yourself, am I solving from the population or am I solving from the sample? Then the mean becomes mu from the population, but the mean from the sample becomes x. It's the same formula. So this is how basically we'll be looking at finding the mean. How about finding the median? Remember, in the median, we mentioned that when finding the median, we simply mentioned that the median is just basically the middlemost value when we were talking about ungrouped data in the previous lesson. So it's just basically finding the middlemost value. So in this case, the data has been grouped into classes. It means it will be somehow difficult to start finding the middlemost value, but instead there is an approach we are going to use. So the median for grouped data is found by this formula. So the middle value of the data, first find the median class. So there is a first step which you have to find. It's the median class. The median class does not indicate that this is my median. We're talking about the median class. Remember, we grouped all the values into classes. So the first step is you locating your median class. Which class is going to have the median value? Remember, there were different classes: 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and so forth. Which among those classes has the median? So how do I find the median class? The median class is found by calculating the position n divided by 2. N divided by 2. So the n is the observation. So if I had 100 observation or 100 scores, 100 divided by 2, it means I'm going to have a 50. So it means my median class is going to be found in the n over 2 cumulative frequency. So there will be an aspect of maybe finding the column for the cumulative frequency again. I'm sure the cumulative frequency, all these we talked about in previous classes. How to come up with a cumulative frequency, how to come up with the frequencies, how to come up with the midpoints, and so forth. So find the median class by calculating the position n over 2. N over 2 in the cumulative frequency. So we are looking for n over 2 in the cumulative frequency. So where I'm going to find n over 2 in the cumulative frequency, that's the median class. So n over 2 is found by the number of observations divided by 2. Number of observations divided by 2, or as I would say, sum of frequencies. So sum up all the frequencies, then you divide by 2. That is the position we are looking for. This position is found in the cumulative frequency. So after doing so, what do? I go in the formula. So this median will now be what? This median will now be equals to this formula. So the formula for the median now becomes median is equals to L plus open bracket n over 2, the position which you found here, minus CF prev. It means the previous cumulative frequency on where you are standing, over FM. FM means the frequency from the median class which you found. So remember, the instance of me finding n over 2 was to find the median class. After I find the median class, I am in that class where the median is. So in the median class, there is a frequency for this class, there is a cumulative frequency for this class. So in that class where I'm standing, CF prev means locate the previous cumulative frequency before you reach to this class. FM means the frequency for the median class. So what is the frequency for this median class? Multiplied by H. Other books or other lectures will simply say multiplied by W. H is just simply called the width of the median class. So remember, what is the width? The width is basically what? The distance between the lower limit and the upper limit. So if my lower limit is 10 and the upper limit is 20, the width is 10. If my lower limit is 20 and the upper limit is 30, the width is 10. So this is what is happening here. In that class, what is your width? So maybe the width is 10 and so forth. So L is the lower boundary of the median class, the lower limit, the lower boundary. So 10 to 20, 10 is the lower limit, 20 is the upper limit. Here 10, 20 to 30, 20 is the lower limit and 30 is the upper limit. So once you locate your median class, you are locating what is the lower boundary for that median class. That's what I'm locating at L. CF is a cumulative frequency before. So L is the lower boundary for the median class. CF is the cumulative frequency before the median class. But FM is the frequency of the median class. And H becomes my class width. So when we'll be finding median, this is how basically I will be finding. Remember, this data cannot be found until we form a cumulative frequency distribution. How do you form a cumulative frequency distribution? Video we made in the first aspect of descriptive data, or maybe trying to visualize data into frequency distribution. Locate that video on how to come up with frequency distribution. So all these cannot be made until you form a cumulative frequency distribution. Always form a cumulative frequency distribution first before coming up with your mean, median, or mode, so that you can replace in those values. The same is happening for the mode. The mode, we're simply saying the mode is just basically the value that occurs most often. So the value with the highest frequency. So the value that occurs most often is basically the mode. It is located in the model class. So it means even when I'm trying to find the mode for grouped data, the first task or the first step, it is me locating what is my model class. Find the model class first. So once I find the model class, we're talking about this is the class with the highest frequency. So in that data which is already grouped, locate which class here has the highest frequency. So once you find that, okay, this is my class with the highest frequency, then grab it, and that is your model class. So in the model class, begin to distribute the following. You have to locate what is your L, because the mode will be using this formula for the mode. So we'll be using this formula. So locate to say, okay, in this model class, what is my L? L, as usual, is the lowest limit in that model class. So if the model class was found from 20 to 30, then the lower limit is 20, because the upper limit is 30. So we're looking at the lower limit for the model class. So if the model class is 20 to 30, in the class from 20 to 30, then the lower limit is 20. Then you look at the values f1 and f0 as well as f2. So there are three frequencies here. There is f1, there is f0, and there is f2. So what do these f1, f0, and f2 mean? So f1 in this formula represents the frequency for the model class. f1 in this formula represents the frequency for the model class. So the frequency for the model class which you located, what is the frequency in that class? That's your f1. f0 represents the previous frequency. So if I'm studying the model class, locate the previous frequency, that's f0. So f1 is in between 0 and 2. So f1 is the frequency for the model class, f0 is the previous frequency, and f2 becomes my frequency of the next class. So in that data which I've already grouped, which I've already formed the cumulative frequency, just begin to locate, okay, what my f1, the previous, my low model frequency, f0, my previous frequency, f2, my next frequency. Replace everything in there, in those operations. So it is f1 minus f0, f1 minus f0 plus f1 minus f2 multiplied by the h. H is the width of the model class. So from 20 to 30, the width is 10. That's my mod formula for grouped data. So from this, what we have formed up to C is basically the measure of central tendency, or others will say the measure of location. Now we got the aspect of the measure of spread. The measure of spread, that's where I find the variancy, the standard deviation, and so forth. So under the measure of spread, we're looking at where this is basically describing how much data varies from the mean. How are the data varying from the mean? How are they spreading from the mean? So the distance between each mean and the data sets. That's how basically the measure of the dispersion is basically talking about. So in this case, we'll be talking about the variancy, just as we talked about the variance in ungrouped data, and we'll also be talking about the standard deviation as well from the ungrouped data, but this time around it is grouped data. So remember, everything the first thing is every time we are looking at solving things from grouped data, we have to recall how to come up with a cumulative frequency distribution. There's a video on cumulative frequency distribution. So form that first. So once you form that, use it to now begin to find all these numerical measures. So what do I have here? I want to find the population variance. If it is a population variance, the parameter is sigma squared. I think we mentioned in the ungrouped data to say population variance, it's this symbol sigma squared, akaka symbol. So this sigma squared, which is the population variance, is found by summing up, which is symbol, which is summation of what? There is an f, which is representing frequency, open bracket x, which is the midpoint, remember, minus mu. Mu is the mean for the population. So what do I need to do first? Midpoint minus mean, the answer you square, the answer times frequency. That's the first point. So on each class, I'll be doing this operation, frequency mod open bracket x minus mean squared, on every class. So after I find all those values from each class, I'll sum them all up. After that, we divide by the observation, which is the capital letter N. Observation. Others will say summation of frequency. But for the sample variance here, the same. Obviously, the statistic we are using is S squared. The statistic we are using is S squared. That's the representation for the sample variance. Summation of f, x minus x bar. X bar is the sample mean, you square. So over n minus 1. What does this mean? N frequency minus 1. So when I'm trying to find the sample variance, once I understand that this is my sample variance, the sample variance is being obtained from, the sample variance is found by summing up f multiplied by x minus x bar squared over n minus 1. But for the population mean, it's just basically, for the population variance, it's just basically over n. So we are using we are simply dividing n minus 1 for samples to correct for bias. So we're just trying to correct for bias, because remember, the sample variance here is just basically a subset of the population. It means we're not trying to consider all the actual individuals there. That is why we use the divide by n minus 1 for samples to correct for bias. That's what we're trying to locate there. So if this is my variance, standard deviation is just very simple. By simply square rooting your variance, then you have your standard deviation. The square root of the variance gives you the standard deviation. As simple as that. So DSO. So with what we've talked about so far, we are now able to solve a certain example using grouped data. So we're simply saying data which is classified into its classes is grouped. Then we'll be talking about central measure of tendency. Are we able to find the mean, mode, or the median? Are we able to find the measure of spread, which is the variance and standard deviation for the grouped data? We have that example there, which we are going to start with. So the example says as follows. A teacher records results of students in a mathematics quiz, and the following are the scores in a frequency table. So what has happened here? The scores of these results have already been grouped for you in a frequency distribution. Score class and its frequencies. They've already been what? Classified for you. Very simple. So a teacher records results of students in mathematics quiz. The following were the scores in a frequency table. So those who obtained result from 1 to 5 were only 2. Frequency talks about the number, how many appeared. So between 1 to 5, we only had 2 students scoring this. Between 6 to 10, we only had 3 students. Between 11 to 15, we only have 4. And between 16 to 20, we only had 1 student. So what are we being told? From the data given, find the mean, median, variance, and standard deviation. From this data, are we able to find the mean, median, mode, and everything? So number 1, what type of data is this? This data is basically grouped data, because data has been classified into what? Certain intervals or certain classes. So we're now going to use it to come up with the mean, median, variance or mode, and everything. Now what did I say? We said that every time when we're trying to deal with grouped data, the first task is form a cumulative frequency distribution. If you do not know how to form this, go to video 2 or video 3 on cumulative frequency distribution. Frequency distributions, how to form that. So form your cumulative frequency distribution. Here it is already, things are already simple for me because I already have class intervals and I already have frequencies. So sometimes if I look at this data, how many students were in the wrote the mathematics quiz? The number of students can be found by summing up the frequencies. So 2 plus 3 plus 4 plus 1 will give me the total number of students who wrote the quiz. So 2 plus 3, that's 5. 5 plus 4, that's 9. 9 plus 1, that's 1. That's 10. So it means I have 10 students who wrote the quiz. of which this will be my observation n. Summation of frequency here is basically our observation n. Summation of frequency gives us observation n. So 10 students, the ones we are using here. So already classified. So we are now forming a cumulative frequency distribution. So a cumulative frequency distribution will look like this. So in this cumulative frequency distribution, there is of course the class, there is the frequency, but for this to be complete, we need to find the midpoint. Remember, in whatever we are doing, we'll be using the midpoint values. So there is a column for the class codes, there is a column for the frequency, and now we are going to introduce a column for the midpoints. So the midpoint is found by lower limit plus upper limit divided by 2. So 1 plus 5 is 6. 6 divided by 2, we have these 3 being formed. In the second row, 6 plus 10, which is 16. 16 divided by 2, we have 8. In the third, 11 plus 15 divided by, the answer divided by 2, you should have that. 16 divided by, plus 20 divided by 2, the answer, you should have that. So this column is having midpoints. This column is having frequencies. That is why I simply said if I sum all the frequencies here, I need to have the observation n. So n is found by summing up all the frequencies. N is found by summing up all the frequencies. So 2 plus 3 plus 4 plus 1 will give me our value of n. Midpoints, we have that. So what am I going to have here? I can now find the summation, or maybe the values of f multiplied by x column. F multiplied by x, because I will use this column in finding the mean. Remember, the formula for the mean according to grouped data is basically summation of f of x, meaning f and x we are multiplying divided by n. So we find f of x and fx here. It means column f and column x. So there is f multiplied by x. F in the first row is 2 and x in the second row, and the other row is 3. So 2 times 3 is giving me this 6. 3 times 8 is giving me this 24. 4 times 18 is giving me this 52. And 1 times 18 is giving me this 18. Then, since I want to find the mean, the formula says sum up the f of x column. So we'll sum all this up. So we'll sum the f of x up. So summing it up, I'll have what? 6 plus 24 plus 52 plus 18. It will give me what? 100. This is the value I'm going to use there. Divided by n. N was what? 10. So implying that the mean is equals to what? Is equals to 10. That's my mean. So therefore my mean, which I'm going to have here, will basically be a 10. Summation of f of x divided by summation of f, which is n, which is 10. Simple as that. We have found our mean. Now I want you to understand that we said that in this non-can distribution, we also have to indicate the cumulative frequency column, because this would help us in finding either the median or the mode. In fact, that's the median. So the frequencies, how do I find the cumulative CF? How do I find the cumulative frequency column? Cumulative frequency column is found by successively adding up all the frequencies. So in the first row here, the frequency is 2. That is why we have the cumulative frequency to be 2 as well. But in the second row here, it is the first frequency plus the second frequency. So it is this 2 plus the second frequency 3, I'm going to have the 5 there. In the third row, it is this 5 plus this 4, which is going to give me a 9. In the last row, it is 9 plus this 1 there, which is going to give me a 10. So cumulative frequency is formed by successively adding up this column of frequencies. So successfully adding up this column of frequencies will have the cumulative frequency. So 0 plus 2, it is 2. 2 plus 3, it is 5. 5 plus 4, it is 9. 9 plus 1, it is 10. To know that you've done the right thing, the final non-value of the cumulative frequency here should be equivalent to the n value. If it is not equivalent to the n value, then something is wrong. So this table is what is going to help me find the mode, and the mode and the median. So when finding the median, what did we say? We have to locate the what? The position first. The position is found by what? N over 2. N is 10, and divided by 2, it means we're looking at 5. So we are looking at the fifth value in the, or maybe the fifth position, the fifth value in the CF. This position is found in the cumulative frequency. So 5, where is 5 going to be found in the cumulative frequency? So 5, this is cumulative frequency 2, it's not a 5, 5 is found here. So this 5 here is what is going to determine my median class. So 10 divided by 2, n divided by 2, I have a 5, which is my position, helping me to come up with the median class. So I'm going to grab my 5 in the column for the cumulative frequency. Where is 5 going to fall? 5 is going to fall in the second row. So it means if 5 is falling in this second row, that's where 5 is. I'm now going to locate my class. My median class is found from 6 to 10. So this class here is our median class. So this class here is my median class, found from the position n over 2. There are some cases whereby you find n over 2, and then maybe in the cumulative frequency you can't locate your 5. For example, this is 2. In the second class, I shall jump up to 9. So 2 in the first row, and then this will, if this was 9, that would have 5. Then what do? You look at where 5 is found. 5 is basically inside the 9 here, because I'm looking at where this value is basically first found. So the 5 is going to be first found at this position. So if this was not 5 but was 9, still this will be qualified because 5 is inside 9. So summing up the frequencies where we are obtaining 5 for the first time, this is why we're trying to locate the cumulative frequency column. So position n over 2, 10 divided by 2, 10 divided by 2 is 5. So locate where 5 is going to be found using the cumulative frequency. So there's 2, there's 5 there. Then the 5 is going to be obtained in the second row. If let's say it was 2 and 9, still the 5 is going to be obtained in the second row, because where 9 is, that's where 5 is inside there. So this is going to be my median class. So remember the formula for the median class. We have to locate, in the median, we have to locate my L, we have to locate my cumulative frequency for the previous, we have to locate the frequency for the median, and so forth. Then we replace in the formula. So L means the lower limit for the median class. So the median class is 6 to 10. So in the notes I made a miniskirt. So the median class is basically 6 to 10. So the lower limit is 6. So that's what we're supposed to have here. The lower limit should be 6 and not 5.5. So this was a miniskirt. So the lower limit here is 6, not 5.5. Because we're talking about the lower limit for the median class. and the median class is basically 6 to 10. So from 6 to 10, this is 6 is my lower limit and 10 is my upper limit. So the lower limit is 6. So grab the 6 and then CF previously. So since 5 is the cumulative frequency for the median class, nearly up, upper position up. So CF previously, it is the previous cumulative frequency, which is the 2. So the previous cumulative frequency is 2. So this is the value of 2 which is going to be there. And then FM means frequency for the median class. So in this row here where the median class is 6 to 10, what is the frequency? My frequency is 3. Every values are coming from this table. If you look at all the values are coming from this table. So 6 to 10, this is my median class. What is the frequency? My frequency is 3. This is the frequency which I'm going to use here as 3. H represents the width. So the width is the distance from the lower to the upper limit. So from 6 to 10, what's the distance here from 6 to 10? So we were talking about 6 to 10, 6, 7, 8, 9, up to 10. We're trying to collect values from 6 to 10. It's basically a width of 5 here, which we're trying to use. So my width is basically 5, because we're collecting from 6 to 10. So 6, 7, 8, 9, 10. There are 5 steps there for me to reach 10. So the width is 5. Replace all the values here, the data collection, the data collected in the formula. Remember, the formula for the median is L plus N over 2, which is the position, minus the previous cumulative frequency over F over M multiplied by the width. This is what we are trying to use here. So this should be 6. The lower limit is 6. Just correct that in as you are writing. So the lower limit is 6 plus this is N over 2. N over 2 is 5 minus the previous frequency here is 2 divided by the frequency of the median class is 3 multiplied by the width, which is 5. So that everything here, when you tabulate, you are going to have the median to be this value. And you are done. So this is basically how everything is going to be formed. Now we go to the aspect of finding the variance and the standard deviation. Remember the formula for the variance? The formula for the variance is summation of this divided by n, isn't it? So what do? This is a sample. This is not a population, but just basically a sample of values. So since this is a sample, we are using the formula summation of x minus x bar squared over n minus 1. So we'll first of all find the chapa mwamba ichi, x minus x bar squared, the answer times its frequency. The answer, after we sum everything up, we'll divide by n minus 1. We know n is already 10. So it will be 10 minus 1 in the denominator, since this is the data coming from the sample. So this is the formula I'm going to use. So let's grab it and use it. So we're going to take step by step. We're going to be finding chapa model upper for each classes. So for class number 1, we find x minus x bar. Class number 2, we find x minus x bar. Class number 3, we find x minus x bar. We'll square times frequency. So this is what I had here. So in class number 1 here, we had the frequency f to be 2. The x value is x. Remember, the mean you've already found is 10. So it means if the mean was wrong in our first calculation, even it will affect even our values here. So I'm just using class number 1. Class number 1, the frequency is 2. 3 minus 10, the answer we square. 3 minus 10 is negative 7. We square. The answer to the square we multiply by 2. We are going to have a 98. We go to class number 3. Class number 3, the frequency is 3. The midpoint is, which x is 8. So 80 minus mean 8 minus 10, the answer we square times the frequency. So this is what I have here. 8 minus 10, the answer we square. After we square, we multiply by the frequency 3, so that we can have a 12. We go to class 3. 13 minus 10. 13 is the x value, 10 is the mean value, 4 is the frequency. In class what? Class 3 here. 4 is the frequency, 13 is the x value, 10 is the mean. So 13 minus 10, the answer we square times the frequency 4. This is what is happening here. 13 minus 10 squared, the answer times 4, so that we can have 36. Class 4, 18 minus 10 squared times 1, so that we can have that. Then we observe this symbol here, which is summation. So it means we are summing the outcome of all these values. So these are the values here. We sum them up all. So summing them up all is 98 plus 12 plus 36 plus 64. It will give us a what? A 210. So therefore, my sample variance becomes summation of this over n minus 1. Summation of this is 210. 210 divided by 10 minus 1, which is a 9, becomes this value as my sample variance. What is the sample standard deviation? Is basically the square root of the variance. So square rooting the variance will have that value there. As simple as that. So with that done, we have the values of what the question talks about. So this is how basically we'll be finding the central measure of tendency and the central measure of location for all the data sets. In the previous lesson, we talked about ungrouped data, and what I've now talked about here is basically grouped data. Thank you very much. The task I'll give you is you going to look at this question. So in this question, this will be a practice question. I don't know if it is visible. Okay, I'll try to send this document in the group, but what I want you to do is solve this question. Last time we talked about ungrouped data. I believe a few people just submitted, and a number of you did submit. So question 1, we said solve question 1, 2, 3 and 4. But I mean question 1, 2 and 3, because this was ungrouped data information. That's what we did we said in the previous lesson, but few people submitted their work. So here now we are adding up another question, which is question 4. So on question 4 there, you make sure you use all the descriptive analysis videos we made, because here it is coming from the aspect of constructing a stem and leaf, and then also coming from the aspect of constructing a distribution, a frequency distribution, and then from there you'll be able to obtain the mode, median, variance and the like, and so forth. So task is question number 4 of this document. I'll send the document in the group, and also if you can, question number 5 and question number 6, so that when this is done, this will conclude our descriptive statistics. So this will conclude our descriptive statistic. So thank you very much for listening. Thank you very much for paying attention. Thank you very much, and see you in our next lesson. Thank you.